Hi everyone, this is Changlan Chen and Yuanzheng's machine learning final project, German to English translator with Seq2seq. We both have learned German in high school, and this is the initial motivation for us to do this project. Our presentation consists of 5 parts. Firstly, we will introduce why translate German is a hard but valuable task. Then we will talk about the data processing and fetching, followed by the introduction of model construction and training. At the end, we will discuss the conclusion of our final project. So, first of all, why is translating German a hard but valuable task? German is the mother tongue of more than 100 million people, and is also a widely used language in academic circles and international organizations like United States. However, it is hard to learn German. According to FSI, from this chart, we can see for English speakers, German is hardest among the European languages, and almost similarly hard to Eastern languages like Indonesian. The famous English classical scholar Richard Porson once complained, "Das Leben ist zu kurz, Deutsch zu lernen." In English, is the life is too short to learn German. Why? Because one major reason is that German have anonymous synonym and sentence structures. Take the single U in English as an example. In German, there is more than 8 translations. Du stands for the singular form of U in first case, dich stands for singular U in second case, and sie stands for plural U in first case, etc. And also, it has many data structures. Take I read a book yesterday as example. In German, there is at least 3 translations. Ich habe gestern ein Buch gelesen. Gestern habe ich ein Buch gelesen. And ein Buch habe ich gestern gelesen. From this example, we can observe that the length, the time, and the verbs could change its position very quickly. And this problem is also a major challenge we face in data processing and model training. Preparation part. After reading data from different databases, we choose these from the beta website. It has 3 assets. Firstly, its language is natural, similar to the real-life use cases. Secondly, the data is succinct, with only a few repetitions, which is for different grammar usage. And lastly, the complexity of the sentences is from easy to hard, which is easier for the machine to learn. However, the original data is in sentences pairs, so we will divide them into word lists. We will first read the file and split them into lines and then into pairs. Secondly, we will normalize the text. We don't want the max length of the sentences to beyond the 20, or it will be too hard for the model to learn. Then we will make the word list from sentences in pairs.
The third part is about our model.
With the dataset preprocessed by Yuanzheng, we're able to train a model with our suitable data to the translation.
The structure of our model is sequence to sequence, in short Seq2seq. It is quite simple because it consists of only 2 parts, an encoder and a decoder. For the encoder, it takes in an input sentence, then pass that to the embedding layer, which will transform a sentence of words into a sequence of numbers. Then the encoder, which is an RNN model, will take the information from current words and the information from the previous words into a summarized information and pass that into the decoder. The decoder, in the training process, will take in also an output target sentence, which is actually the input here. And it will give out the probability based on the information from the encoder and the current words, predict the next word, and passing that prediction, the probability, into the softmax function, which will decide which word is of the greatest possibility at this position and generate the output. The next part is the coding of our structure. On the left-hand side is an encoder RNN, which has two layers, an embedding and a GRU. I chose GRU because for our task, we would input a sentence of tens of words. If the model can decide to forget or to remember that information from the previous sentence of previous words, it would be better for the training process. And I chose GRU rather than LSTM because LSTM is more consuming than the GRU, and for this individual training task, the less computing power required, the better it is. And for the right-hand side is our decoder RNN. It has actually 5 layers. An embedding for the training process to get the target input, and a rally layer to further process the embedding information. Then the GRU will perform what I described in the previous slide and pass that into a linear function followed by a softmax function to generate the output. After the model is built, there are some parameters and the loss functions to choose from. The first one is the teacher forcing, which is a new concept for us. The teacher forcing is an algorithm used to train RNN weights. It includes feeding back the observed sequence values, in other words, the ground truth, to the RNN after each step, thereby forcing the RNN to remain close to the ground truth sequence. In other words, this is to take the ground truth output as the input for the decoder part instead of the prediction of the decoder. This process will make the convergence faster. However, after some training steps, it will remain unstable. That's why I set up a teacher forcing ratio to 0.5 and a random generator to generate numbers from 0 to 1 to decide if this step perform the teacher forcing. The final part of this section is about the loss function. There are some difficulties I encountered when choosing which loss function is the better. The first one is that in every language there are always some synonyms existing. In the picture above, we can see that I'm going home and I'm on my way home. The going and on my way are both corresponding to the same meaning of auf dem Weg in German. It is quite simple for humans to decide that these two sentences have the same meaning, but for a loss function or machine, it's really hard. And the second thing is about the structure of the sentence. In English, I'm going to miss your cooking. Miss is following the first verb of be going. However, in German, wir werden eure Kochkünste fehlen. The fehlen is actually the second verb, and it is at the end of the sentence. And there are some word orders of the German sentence that can be changed, such as the German sentence can also be formed like eure Kochkünste werden mir fehlen, and alike. It is also easy for humans, but hard for the machines. Eventually, found the negative loss likelihood loss suitable for our case. The formula is below, and it is originally used for the classification problem that you decide if this greatest probability of this class is suitable among all those classes, and is similar to our problem that we are choosing the word of the greatest possibility among all words. The fourth part is a demo for our application.
Using our application is actually quite simple. You can straightly type in the German sentences in the left box, and after that, click the translation button, which will translate the English sentence into German, and clearing the clear button will clear out any sentence or output in the two boxes.
The final part of our presentation is our conclusion and reflection. It has 3 components. First of all is the data. If we had more time, we would use more variants of words and phrases, because as we know, in English, there are only 2 conjugations of verbs, but in German, there are actually 6 conjugations of each verb, and without the stemming process, our model is unable to translate or find the 2 conjugations of a same verb are the same. That's why we would do more variants of words and the stemming in the next step. The second one is a model. Our Seq2seq model is actually quite simple for such a complex task of machine translation. And for the first steps, we would use complex models with attention or the cutting-edge transformers models. Because our model is actually limited to the sentences starting with a primary verb of be verb and some subordinate clauses. And for the training process, if we obtained a more complex model, then it will be able to train more sentences with regular verbs and other complex clauses of structures, so that we can obtain a model that can translate nearly any sentence in German into English. And that's all about our presentation. Dankeschön. Thanks.